Welcome to another deep dive. You know how this works. You send us the sources, and we jump in.
Head first.
Yeah, into the deep end. We try and figure out what it all means and bring you those key takeaways that leave you feeling like, okay, I get it now. That was worth the time. Not like I just wasted an hour of my life and I don't know anything more than I did before.
Right, we don't want that.
No, no, we don't. So today's deep dive is based on a bunch of research articles and book chapters that you sent us, all centered around this idea that classroom discussion can actually boost your reasoning abilities.
Yeah, the core question here is like, could the way you talk about science and math in a classroom setting actually make you better at solving, totally different kinds of problems later on?
Right, and it's not just like, oh, you learn how to think better in general. It's specifically about abstract reasoning. Like, could those conversations about buoyancy or quadratic equations somehow be secretly training your brain to ace those nonverbal reasoning tests, the ones with the visual patterns and shapes?
It's like, could talking more in class actually make you better at tests that don't even involve words?
Yeah, it's pretty mind-blowing when you think about it. Like, your brain's getting this workout in ways you wouldn't expect just by participating in a classroom conversation.
It really gets to the heart of a really big question about education. Does what you learn in one area really transfer to other areas of your life? We talk about the transfer of learning all the time, but we're usually talking about what's called near transfer, like when you use a skill in a very similar situation.
Right, like if you learn how to solve for X in algebra class, and then you can use that skill to solve for Y in a slightly different type of equation.
Exactly. But what we're talking about here is far transfer. Can you apply what you learned to a situation that is completely different, a totally new context?
And that's a big question. Does all that time spent in school actually make you a better thinker in general? Or are the benefits mostly limited to the specific subjects you studied? Like if you spent years learning calculus, did that somehow make you better at arguing your point in a debate, even though there's no direct overlap in terms of the content?
That's the kind of thing these researchers were trying to figure out.
Okay, so to understand how this might even be possible, we need to step back a bit and look at how the thinking about science education has evolved over time.
Right, because for a long time, the dominant view was that learning was a very individualistic process. Like it was you on your own interacting with the world and building your understanding internally.
Yeah, like your brain is this little isolated machine just processing information on its own.
That's right. That view was influenced a lot by Piaget, who focused heavily on individual cognitive development.
But more recently, there's been this shift towards a different view called social constructivism. This idea comes from Vygotsky.
Yeah.
And his perspective highlights that knowledge isn't just something you build in isolation. It's actually constructed through your interactions with other people.
It's like your thinking is shaped by the conversations you have, the arguments you make, the questions you ask and answer together.
Exactly. And that's where classroom discussion becomes really important. It's not just a nice to have, it's actually a crucial part of the learning process, according to this view.
Right, because in a good discussion, you're not just passively absorbing information, you're actively constructing meaning together.
And it's not just a nice idea in theory. There's actually research that supports the benefits of this kind of discussion-based learning.
Oh, yeah, for sure. There have been a lot of studies that have shown that students who participate in classroom discussions perform better in a whole range of subjects, not just science, but also math and even language.
Which makes sense, I guess, if you think about it. Like if you're constantly having to explain your thinking, justify your reasoning, and respond to other people's ideas, that's bound to make you a more flexible and adaptable thinker.
Right, and it's not just about getting the right answer, it's about learning how to think about problems in a more nuanced way.
Okay, so we've established that discussion is important. But it sounds like it's not just any old classroom chatter that's going to lead to these benefits. There's this specific type of talk that researchers have identified as being particularly effective. It's called exploratory talk.
Yeah, exploratory talk. It's not just about sharing ideas, it's about exploring those ideas together, like really digging into them.
So what exactly is exploratory talk, and how is it different from just, shooting the breeze with your classmates?
Well, imagine different types of conversations you might have in a classroom. Sometimes you have like disputational talk where people are just disagreeing and arguing without really making any progress. It's like, I'm right, you're wrong, and nobody's really listening to each other.
Yeah, that doesn't sound very productive.
No, not really. And then there's cumulative talk, where people are just kind of agreeing with each other and adding on to each other's ideas, but nobody's really challenging anything, so you're not really pushing your thinking.
So it's like everyone's just nodding their heads and saying, yep, yep, I agree.
Exactly. But exploratory talk is different. It's more like a genuine back and forth, where people are really trying to understand each other's perspectives.
So it's not just about being right or wrong. It's about trying to figure things out together.
Exactly. In exploratory talk, people share their ideas openly. They listen to each other carefully, they ask questions, and they try to understand the reasoning behind each other's views.
And when there are disagreements, it's not just about arguing your point. It's about trying to understand where the other person's coming from and finding a way to move forward together.
Exactly. You might offer counter-arguments, but you do it in a respectful way that's focused on clarifying the issue and reaching a shared understanding.
So it's about thinking out loud together, but in a structured and productive way.
Right. And the research suggests that when students engage in this kind of exploratory talk, they not only learn the specific content better, but they also develop these more general reasoning skills that can be applied in other areas of their lives.
Okay, so it sounds like there are a lot of potential benefits to exploratory talk, but it also sounds like it's not something that just happens naturally. You need to create the right conditions for it to occur.
That's right. It's not enough to just throw a bunch of kids in a room and tell them to discuss. You need to be intentional about it.
So what are some of the things that teachers can do to foster exploratory talk in their classrooms?
Well, first of all, you need to make sure that students understand what exploratory talk is and why it's important. You need to explicitly teach them the skills involved in having these kinds of productive discussions.
Like how to listen actively, how to ask clarifying questions, how to construct a reasoned argument, that kind of thing.
Exactly. And it's also important to establish some ground rules for discussion.
Right, because without some guidelines, things can easily devolve into chaos.
Exactly. Researchers like Rojas Drummond and Mercer have emphasized the importance of having these clear ground rules.
And it's not just about the teacher laying down the law. It's about creating these rules together with the students so that everyone feels a sense of ownership and buy-in.
Right. It's about creating a culture of respectful and productive discussion.
And what are some examples of these ground rules?
Well, they usually focus on things like showing mutual respect for each other and each other's ideas, ensuring that everyone shares relevant information, being open to having your ideas challenged, and offering reasoned rebuttals, and actively working towards agreement on the claims being made.
So it's about creating a space where it's safe to disagree, but also where everyone is committed to working together to reach a shared understanding.
Exactly. It's about creating a community of inquiry.
Now, how do researchers actually measure if this exploratory talk is happening in a classroom? They can't exactly put a number on the quality of a conversation, can they?
Well, not with a single number, no. But they have developed methods to assess it.
So how do they do it?
One common approach is to record classroom discussions and then analyze the transcripts. They look for the frequency of certain linguistic features that are associated with exploratory talk.
Like what kinds of features?
Things like the use of connecting words, like because, or expressions of agreement, or phrases like I think or I disagree because. These kinds of words and phrases can indicate that students are engaging in more complex reasoning and that they're trying to understand each other's perspectives.
Interesting. So it's like dissecting the conversation to see if it has the hallmarks of exploratory talk.
Exactly. And they also look at the length and complexity of students' contributions, as well as the overall flow of the conversation.
So if students are giving longer responses, using more sophisticated vocabulary, and building on each other's ideas, that would be a good sign that exploratory talk is happening.
Exactly.
Okay, so we've talked about exploratory talk and how it can benefit students in specific subjects, like science and math. But how do we connect this to the idea of abstract reasoning and this far transfer that we're so interested in?
Right, that's the big question. How do we know if these discussion skills are transferring to other areas of cognition?
And this is where the Raven's test comes in, right?
Yes, exactly. The Raven Standard Progressive Matrices, or RSPM, is a really widely used test of nonverbal abstract reasoning.
Nonverbal meaning that it doesn't involve any language.
Right. It's all about visual patterns. You're presented with a series of matrices, which are basically these grids with a missing piece, and you have to figure out which of the available options best completes the pattern.
And the idea is that this test taps into some fundamental cognitive abilities that are important for a wide range of tasks, like problem solving, critical thinking, and even creativity.
Exactly. It's often seen as a measure of what Spearman called G, or general intelligence. It's like a measure of your raw brain power, the ability to see patterns, make inferences, and solve novel problems.
Okay, so the RSPM is considered a good measure of abstract reasoning ability. But traditionally, it's been viewed as being pretty independent of language and culture. Like, it doesn't matter what language you speak or where you grew up, you should be able to perform well on the Ravens test.
Right. And that's why it's been used so widely in research, because it's seen as a relatively unbiased way to assess cognitive ability.
But it sounds like that traditional view is being challenged somewhat.
Yeah, there's a growing body of research that suggests that even nonverbal reasoning might be influenced by language and social interaction.
So maybe it's not as separate from our experiences and our cultural backgrounds as we once thought.
Exactly. The idea is that our cognitive abilities are shaped by this complex interplay between our internal mental processes and our interactions with the world around us.
And those interactions are often mediated by language, right?
Exactly. So even though the Ravens test itself doesn't involve language, our ability to perform well on it might be influenced by our language skills and our experiences with social interaction.
Okay, so that's a really interesting shift in thinking. But how do we know if it's actually true? Like, how do we measure this potential influence of language and social interaction on nonverbal reasoning?
Well, that's where the research on exploratory talk comes in. Because if language and social interaction really do influence our nonverbal reasoning abilities, then we would expect to see improvements in Raven's test scores among students who engage in exploratory talk.
And that's exactly what some researchers set out to test.
Right. A group of researchers at the University of Port Elizabeth in South Africa conducted a series of studies that specifically looked at the relationship between exploratory talk and performance on the Ravens test.
And these were pretty rigorous studies, right?
Oh, yeah, absolutely. They used a quasi-experimental design, which means that they had experimental groups and control groups, and they measured the students' Ravens test scores both before and after the intervention.
And the interventions were pretty intensive too, right?
Yeah, they lasted for 6 to 9 months, and they involved training teachers to implement exploratory talk in their science and math classrooms.
So they weren't just giving students a few lessons on how to have better discussions. They were really trying to embed exploratory talk into the fabric of the classroom culture.
Exactly. And the ways they encouraged exploratory talk were quite varied. Sometimes they used conversational readings as starting points for discussions. Other times they put up prompt posters to guide the conversations. And they also incorporated a lot of hands-on practical work.
And the crucial thing is that the focus of these discussions was always on the science and math content itself. They weren't teaching the students strategies for how to solve Raven's test problems or anything like that.
Right. They were just trying to get the students to engage in more high-quality discussions about the subject matter.
And then they used the Raven's test as this independent measure to see if there were any broader cognitive benefits to this kind of talk.
Exactly. It was like a test of far transfer.
And what did they find?
The findings were really quite remarkable. Across several of these studies, they found that students in the experimental groups, the ones who had participated in exploratory talk, showed significant gains in their Ravens test scores.
So just by having better conversations about science and math, these students were actually getting better at solving abstract visual puzzles.
Exactly. And these weren't just small, statistically insignificant changes. The improvements were often quite substantial.
Wow, that's pretty impressive. And you said that these findings were consistent across several studies.
Yes. Researchers such as Webb and Tregist, Villanueva, and Sepeng all reported similar results. They all found that exploratory talk was associated with significant improvements in Raven's test scores.
So it wasn't just a fluke or a one-off finding. It seems like there's a real pattern here.
Exactly. And interestingly, there was one study where exploratory talk didn't really take hold in the classroom, and in that study, they didn't see any significant improvement in Raven's scores.
So that suggests that it's really the exploratory talk itself that's driving these games, not just any kind of classroom interaction.
Exactly. It seems like there's something about the specific nature of exploratory talk that's particularly beneficial for cognitive development.
Okay, so that's pretty compelling evidence for far transfer. But how do we explain it? What's going on in the brain during these exploratory discussions that leads to this broader improvement in abstract reasoning skills?
That's the million-dollar question, and the researchers have proposed several possible explanations.
So what are some of the leading theories?
Well, one idea is that exploratory talk might be implicitly promoting some really effective learning techniques.
Like what kinds of techniques?
Things like retrieval practice, where you have to recall information from memory in order to participate in the discussion, or distributed practice, where you're revisiting concepts over time, or even interleaving, where you're connecting different ideas together.
Right. So it's not just about passively absorbing information. You're actually having to actively engage with the material and make connections between different concepts.
Exactly. And the act of constructing an argument and responding to counter-arguments could also be seen as a form of deliberate practice in reasoning.
So it's like you're getting all these mini workouts in critical thinking and problem solving just by participating in the discussion.
Right. But there's another possibility. Maybe it's not just about the specific learning techniques. Maybe exploratory talk is actually shaping the way students think on a more fundamental level.
Okay, I like that. So it's not just about learning how to learn, it's about changing the structure of your thinking itself.
Exactly. One possibility is that exploratory talk is explicitly teaching students how to structure an argument.
Right, because to participate effectively in an exploratory discussion, you need to be able to organize your thoughts, present evidence, and consider different perspectives.
Exactly. And this repeated practice in structuring arguments verbally might then transfer to other domains, like solving abstract visual puzzles or writing persuasive essays.
So it's like you're learning these mental habits that can be applied in a variety of contexts.
Exactly. And it's not just about argument structure. It's also possible that exploratory talk is improving students' working memory capacity.
Working memory is basically the amount of information you can hold in your mind at one time.
Right. And it's a really important cognitive ability that's linked to a lot of other things like fluid intelligence and academic achievement.
And some research suggests that it's possible to train your working memory, right?
Yeah, there's some evidence for that, but the findings are still pretty mixed.
But it's possible that exploratory talk is providing this indirect working memory training just by requiring students to hold multiple ideas in mind and manipulate them verbally.
Right. And it's also been suggested that exploratory talk might be improving students' attentional focus and reducing mind wandering.
Which would make sense, because if you're really engaged in a discussion, you're less likely to let your mind wander off to other things.
Exactly. And that improved attentional focus could then transfer to other tasks like solving complex problems or studying for a test.
So it sounds like there are a lot of potential cognitive benefits to exploratory talk. But it's not just about the cognitive stuff, right? There's also the social and motivational aspect to consider.
Oh, absolutely. The social and motivational side of things is huge because when you're engaged in a good discussion, you feel heard, you feel valued, and you feel like your ideas matter.
And that can be really motivating, right?
Totally. It can make you want to learn more, participate more, and push yourself harder.
And it can also boost your confidence and your self-efficacy, which are both really important for success in any area of life.
Exactly. So it's not just about the cold, hard cognitive skills. It's also about creating this positive learning environment where students feel supported and encouraged to take risks.
And that kind of environment can be really transformative, especially for students who might not have had positive learning experiences in the past.
Right. It can really change their whole attitude towards learning.
Okay, so it sounds like exploratory talk has a lot going for it, but it's important to remember that it's not just any kind of social interaction that's going to lead to these benefits.
Right. It's the specific characteristics of exploratory talk that seem to be important.
So it's not just about chatting with your friends or arguing with your classmates. It's about engaging in this structured and purposeful dialogue that's focused on understanding and building on each other's ideas.
Exactly. And that's what the researchers mean when they talk about the nature of the talk.
Right. It's not just about the language being used. Although in these studies, they did find that encouraging students to use their home language helped them engage more deeply in the discussions.
Yeah, that's an interesting finding. It suggests that when students feel comfortable using their own language, they're more likely to share their ideas and participate fully in the discussion.
Which makes sense, I guess. Because if you're struggling to express yourself in a second language, you're probably less likely to speak up and share your thoughts.
Right. But ultimately, it's not just about the language. It's about the kind of thinking that the structure of exploratory talk encourages. It's about verbalizing your reasoning, engaging with different perspectives, and working towards a shared understanding.
So the key takeaway here is that exploratory talk seems to have the potential to benefit students in a lot of different ways.
Exactly. It can help them learn specific content better, develop more general reasoning skills, improve their working memory capacity, boost their motivation and engagement, and even change their whole attitude towards learning.
And it's not just limited to science and math, right?
No, not at all. The principles of exploratory talk can be applied in any subject area.
And it could be particularly beneficial for students who are struggling academically or who come from disadvantaged backgrounds.
Right, because exploratory talk can help level the playing field by giving everyone a voice and encouraging them to participate in the learning process.
So there's a lot of potential here, but it's important to remember that this is still a relatively new area of research.
Right, there's still a lot we don't know about how exploratory talk works and how to implement it most effectively in the classroom.
But the evidence we have so far is definitely promising.
Absolutely. I think exploratory talk has the potential to really revolutionize the way we think about teaching and learning.
So to bring this deep dive to a close for you, the listener, the research we've explored today suggests that engaging in structured classroom discussions, this exploratory talk, can lead to some pretty amazing improvements in your cognitive abilities, including your abstract reasoning skills. And that's not just about acing those standardized tests, it's about becoming a more flexible, adaptable, and creative thinker.
It's about reaching your full cognitive potential.
Exactly. So here's something to think about. How can you incorporate more exploratory talk into your own life? It doesn't have to be limited to the classroom. You can use the principles of exploratory talk in your workplace, in your community groups, and even in your personal relationships.
It's really just about having more intentional and productive conversations.
Exactly. So the next time you're faced with a challenge or a problem to solve, consider having an exploratory talk about it with someone you trust. You might be surprised at how much it helps you clarify your thinking, generate new ideas, and come up with creative solutions.
And who knows, you might even find that you're becoming a better thinker in the process.
That's all for today's deep dive. Thanks for listening.
Thanks for diving in with us.